Hello my dear lovely students. Now in this video we find out the expression for fringe width in young dove slit experiment. As we know that S is the narrow slit which is illuminated by the monochromatic light of wavelength lambda. S1 and S2 are two also narrow slit. Now the path difference P is equal to S2P minus S1P, S2P minus S1P. Okay. For right angled triangle S2BP minus and S1AP, S2P square minus S1P square, S2P square minus S1P square is equal to S2B square plus PB square plus PB square. S2 B square plus PB square plus PB square minus S1P square is equal to S1A square plus P square. S2B or S1B equal to D. So we write here D square plus X plus D square minus D square plus X minus D by square. Okay, so S2P at the place of S2P square minus S1P square, we put S1P minus S2P minus S1P into S2P plus S1P as A square minus B square is equal to A plus B into A minus B. So S2P minus S1P बराबर S2P plus S1P बराबर 2XD. Okay, we simplified it, it is equal to 2XD. So S2P minus S1P is equal to 2XD by S2P plus S1P. At the point P is very close to A, so S2P equal to S1P, we write D, so P is equal to 2XD by D plus D, so 2XD by D plus D is equal to 2D, we cancel 2 by 2, so P is equal to XD by D, where P is equal to path difference. Now the position for bright fringe. The position for bright fringe for constructive interference, P is equal to XD, X small d by capital D, P is equal to XD by D is equal to N lambda. As we know that from young double slit experiment, the bright fringe or constructive interference, the path difference is N lambda. So X is equal to N D lambda by D. As we put n is equal to 0, the whole term is 0. As we put n is equal to 1, so d lambda by 2. As we place n is equal to 2, so 2d lambda by 2. As we place n is equal to 3, so x barabar 3 d lambda by 3, and the series is going on and on. Now the position for dark fringe, P is equal to x d by d. As we place is equal to 2n minus 1 lambda by 2 for dark fringe or destructive interference. The path difference is 2n minus 1 lambda by 2. So x is equal to 2n minus 1 lambda d by 2d. So if we place 1, so half d lambda by t. When we place 2, so is equal to 3 by 2 d lambda by t. When we place 3, is equal to 5 by 2 d lambda by t, and the series is going on. Now the fringe width. What is the fringe width? Fringe width equal to separation between two consecutive finger bright fringe. So we represent P fringe width is equal to beta. Beta is equal to xn minus 1. So at the place of xn, we write n d lambda by d minus n minus 1 inside the bracket into d lambda by d, and after simplification beta, as we know that the beta is the fringe width, so fringe width is equal to d lambda by d, where beta represents fringe width, d the separation between the source and the screen. Now the sustained interference pattern. What is the sustained interference pattern? The interference pattern in which the position of maxima and minima of intensity on the observation screen do not change with time is called a sustained or permanent interference pattern. So as we know that the sustained and permanent is the same thing, it is not the two different things, they gives the same effect. So this permanent and sustained is the same pattern. So it's what it mean? It mean the position of maxima and minima cannot be changed with respect to time. The intensity of maxima and minima on the observation screen cannot be changed with respect to time. That is called sustained or interference pattern. The interference pattern in which the position of maxima and minima of intensity on the observation screen do not change with time is called a sustained or permanent interference pattern. For condition first, the two sources continuously emits waves of same frequency. Now the second condition, the sources are coherent. The third condition, the amplitude of the interfering waves should be equal. The amplitude of the interfering waves should be equal. Now the fourth condition is the two sources must be narrow, and the fifth condition is the sources should be monochromatic. So the five conditions must be obeying for obtaining the sustained interference pattern. The first one is the two sources continuously emits wave of same frequency. The sources are coherent. The third one, the amplitude of the interfering waves should be equal. The fourth one, the two sources must be narrow, and the fifth one, the sources should be monochromatic. Now the ratio of amplitude as is intensity, as we know that the intensity of wave is directly proportional to the square of amplitude. So I1 by I2 is equal to A1 square by A2 square. For maxima, we know that is A1 plus A2, and for minima, as we know that A1 minus A2. So I max by I min is equal to A1 plus A2 square by A2 minus A2, A1 minus A2 square. For as we divided by A2 in both part. So A1 by A2 plus A2 by A2 square by A1 by A2 minus A2 by A2 square. So A1 by A2 plus A2 by A2 is equal to 1. So A1 plus A2 plus 1 by A1 minus A2 minus 1 square. Okay, so I max by I min बराबर equal to R plus 1 square by R minus 1 का square, where R is equal to A1 by A2 is equal to root under I1 by I2 is equal to amplitude ratio of two waves. That's all, and in the next video we discuss about diffraction. Till then, goodbye.